have learnt about the combination of resistances. Now we will discuss about the other resistances present in the circuit. This is current circuit. What are those? The internal resistance of the cell. So we will now learn about what is internal resistance and what is E.M.F, what is terminal potential difference. So we know that cell is the source of DC current or battery eliminator we talk. So when there are more than one cell, then we call it as a battery, and if it is a single, we call it as a cell. These are the sources of DC direct current. Now, direct currents are the unidirectional current. We don't have the fluctuation, that we don't have the positive and negative values. Now, when there is a cell basically they have electrolyte inside it, and there are the plates. These plates are, one is called as anode, another is called as cathode. Now, within the cell, the ions move from one end to the another end. The flow of ions are responsible for the current in the circuit. Outside the circuit, the electrons are flowing, but inside the electrolyte, inside the cell, the ions are moving from one plate to another plate. The cations, they will go to cathode plate, the anions, they will go to the anode plate. Now, what is internal resistance? It is the resistance offered by the cell to the flow of ions. It is the resistance offered by the electrolyte to the flow of ions inside the cell. Now, the internal resistance, it is denoted by small r and it is measured in ohm. The factors on which the internal resistance depends, these are the nature of the electrolyte, the area of the plate, the separation between the plates, and the temperature. Now, when we increase the area, then the internal resistance will decrease. When the separation between the plates will be decreased, the internal resistance will decrease. When the electrolyte is ionic, then the internal resistance is less. And when it is covalent or organic, then the internal resistance is more. And when the temperature is high, then the internal energy is low. So because of this temperature, the internal resistance of the electrolyte will decrease. So the factors on which the internal resistance of the cell depends, we know that these are the temperature, these are the area of the plate, the separation between the plates, the nature of the electrolyte, and many more other factors are there. What is E.M.F? What is E.M.F? The E.M.F is electromotive force. Electromotive force. It is not a force. It is not a force, but it has been termed as electromotive force. Now, what is the reason for it? Look at here. If this is the cell, this is the bulb, and there is a switch out here. As soon as we will switch on, what will happen? The bulb will glow. Now, why the bulb will glow? Why? Because the flow of electron will take place. The flow of electron will be outside the cell, but inside the cell there will be the flow of the ions, the cations and anions. Now, once these electrons, they flow from the electron flow from the negative terminal to the positive terminal, while the direction, the conventional direction of the current is always from positive to negative. Now, when these electrons, when I will switch on the circuit, then the bulb will glow. Now, the bulb will glow because the electrons are flowing. Now, these electrons, or the electron which is flowing from here, it will reach to the positive plate out here. Now, as soon as it will reach to the positive plate, these electrons will not move to the negative plate because the electron will be repelled by the negative plate. Now, so what will happen? Then the bulb will not glow further, but we want the bulb to glow further. So for that reason, we will have to do some work. We will have to do work on those electrons to move it from the positive plate to the negative plate, that is anode to cathode inside the cell. Or we can say in other words, to move positive charges from the negative plate to the positive plate. So what is E.M.F? It is the amount of work done to carry the electrons from the positive plate to the negative plate inside the cell, or it is the amount of work done to carry the positive charge from the negative plate to the positive plate. So you can also say that the positive plate is a higher potential, this is a lower potential. So when you are carrying a positive charge from lower to the higher, or electron from higher to lower, then that amount of work done is said to be E.M.F. It is measured in volts. It is measured in volts. Now, there is another term known as terminal potential difference, terminal PD. Now, what is a terminal PD? It is the difference in potential at the two terminals of the cell when the current is being drawn from it. So when we are drawing a current from the cell, then the potential difference across the cell is called terminal potential difference, and it is denoted by capital V. The E.M.F of the cell is denoted by capital E. Now, what is the relationship between them? The current, if the current I is flowing through it and the resistance, the external resistance is R, then the terminal PD is I IR, right? And the EMF E, that will be V plus IR. So, what will be the current in the circuit? What will be the current in the circuit where there is an internal resistance? So, I will be E minus V. You can see from here.